now. Other than that, let's walk through the agenda for today's meetup, just the outline of what I was planning. So first of all, we're going to have a look at what DevOps is, like a little bit of a definition, a little bit of background, like is there actually a problem we're trying to solve? Like why are we doing this in the first place? Then we'll look at CAMS, which is an abbreviation I'll tell you more about once we get there, which we will be exploring right after. So we will be exploring every letter in there, which sort of defines what DevOps is. And then we'll look at the DevOps stages, because like knowing what DevOps is and then starting doing it are two really different things. And if you start doing DevOps, you'll notice you'll like move through different stages. So this should give you a little bit of a heads up if you're just starting, like what can you expect to face? Or if you're currently like in the middle of something, sort of like give you a sense of where you are at. And then finally, there's a couple of things that I think are useful and can really help you be successful in doing DevOps. Having said that, any questions at this point? All right, so let's get started. What is DevOps? So I picked a definition from the internet, from Wikipedia a couple of years ago. It's different now, but I like this one better. So DevOps is a culture, movement, or practice that emphasizes the collaboration and communication of both software developers and other IT professionals while automating the process of software delivery and infrastructure changes. That's a lot of words, but the key parts from this one are both software developers and other IT professionals. I think over the years, DevOps has sort of snowballed into DevSecOps and then BizDevSecOps, and there's like all kinds of other like terms or functions or roles or whatever being added to it. And I think DevOps was intended to capture that from the outset, right? It's not just development and operations, even though the examples we're going to be looking at might be focused on development and operations. I think this is broader than this. I think the whole point of DevOps is to make sure there's more collaboration across the organization towards that common goal. And the problem really traditionally is this: you have the business sort of orchestrating everything, like little puppets, like little puppet masters, like moving the puppets around. So there's development teams on one hand, there's operations and other IT professionals on the other, and then there's this big, massive wall in between, right? So these people really don't talk to each other. Development, like develop something, they build something, then they throw it over that wall onto operations, and they do whatever they need to do with it in order to get it live and keep it running, right? But what you end up with is two different worlds. One where the developers keep saying, hey, I want change. And then operations keep saying, I want stability. And that's all because everything is like thrown over that wall of confusion, as it will, right? So sort of handing it over, it's your problem now. What's going to happen if there's like these two competing goals, as it were, is that ops is going to say, no, we want stability, so no change. And dev is going to say like, hey, you don't ever change anything. And so they're becoming opposites. And the thing that DevOps tries to tackle, tries to like move towards to, is getting more towards a handshake, more towards a collaboration, and really breaking down that wall of confusion that is in between these two. Any questions about this so far?
Doing great.
Thanks, Humphrey. All right, so let's look at CAMS, which is really what this is all about, what DevOps is all about for me. CAMS stands for culture, automate everything, measure everything, and share everything. CAMS is really easy to remember what DevOps is all about, but as you'll notice as we go along, as this blows up into a lot of different pieces. So it's a lot harder than it actually looks. And at the same time, it's also very easy to get started. Let's look at the first one. Let's look at culture. Culture, I think, is one of the more fundamental things in DevOps for me. And as I mentioned before, it's all about breaking down those barriers, about breaking down those walls that exist within organizations. And it's not just between development and operations. As I said before, it's other IT professionals as well, right? If you're unlucky, you're still in a very traditional organization that is completely siloed. And if you have to build something, it has to go like through 3, 4, 5, 6, 7 different silos before it actually gets delivered or gets released or published, or depending on what you're working on, right? And those organizational barriers, again, they sort of cause this internal competition within an organization, because each of these like silos has their own set of goals. And unfortunately, they're not always exactly the same goals, right? So they're all like moving into a slightly different direction. And that is really painful for an organization, because that means you're definitely not as effective as you could be. So breaking down those barriers, and that's what I mean when I said it's a hard one too, is like it's hard to change that, but there's a lot you can there's a lot of easy things you can do to get started, is by just looking up those people that are in those other silos and just start collaborating with them without necessarily making any organizational challenges. Obviously, you're gonna run into some sort of glass ceiling at one point where there's only so much you can do without changing the organization, right? But it's a very important and very pivotal step. The next one for culture, and it's sort of a given, but it remains so incredibly important. And unfortunately, I don't see too many people having continued awareness on this, is the Agile Manifesto, right? If you carefully look at the Agile Manifesto, like there's nothing in there that contradicts DevOps. Even more so, I think the whole intention behind that was DevOps, meaning that we need all the people in the team that we need to deliver something from request to like getting it live into production, right? That's everybody we need. We need like autonomous self-organizing teams that can effectively deliver value in 1 month or less, and their sole focus is on delivering that value. Having said that, the goal is working software or working systems. And if you look at the Agile Manifesto, there is working software over, no, it's not working software. Now I'm blanking on the Agile Manifesto. Just as I said, not too many people actually know about this. But the working software is incredibly important, but it's more than software, right? It can be systems, it can be solutions. Replace that term with whatever suits your environment, right? Because that is ultimately the reason why we're doing all this. That's the reason organizations become agile, because they need that working software, because that's where the true value is for customers. A little bit of what I said before as well, like you build it, you run it, that self-organizing autonomous team, right? The whole point of DevOps is that it's no longer the case that you develop something and then you hand it over to somebody else and they take it with them and they are responsible if something goes down. No, the whole point of DevOps is that if you build it, you run it. That means that if you build something that breaks down, you're going to be the team to fix it. And this is often a really strong point of contention, especially when you start with DevOps, is that, yeah, suddenly the whole team has to start doing pager duty. And because like if you merge Dev and Ops, those Ops people are typically used to having pager duty and being on call for any outages and everything. And now they're merging with these development people that have never really been in that situation. That leads to some friction, right? So a lot of interesting conversation, but the whole point is, if you build stuff that doesn't break down in the first place, if you collaborate from the start, dev and operations, just an example to keep it simple, then your pager duty becomes sort of like trivial, like it's already like it doesn't really matter because nothing goes down, right? So ultimately you probably don't need it anymore, or it's like a once a year kind of deal. But that responsibility, that ownership is incredibly important, because if people don't have that, they're still not going to make that effort that they should be making in order to get those stable systems, get that working software out there. And then finally, part of culture is also going to be the other things, right? Automate everything, measure everything, share everything. That has to become like a part of your culture. So we're going to explore those next. I just want to pause here briefly, see if there are any questions at this point. All right, no questions. So let's move on from culture to automate everything. And with automate everything, I literally mean everything, right? It typically starts with test automation, which is easy to get into, easy to get started with. And it's a very sensible first step for organizations that are looking not only to move towards DevOps, but also to move towards continuous integration, continuous delivery. Test automation low key, and it typically starts with unit tests, right? Testing small individual units, separate units of business logic, and making sure they keep working whatever changes you make, right? And on top of that, there's going to be integration testing, there's going to be user acceptance testing, user interface testing, all these kinds of things, right? You start with unit tests, obviously, because they're very quick to run, they're very small to build, and you can run like thousands at the same time. And so they're really effective. So test automation, one of the first steps to take. Another big win in automation is infrastructure as code. And unfortunately, with more and more organizations embracing public cloud, this becomes more of like a default way of operating, because doing things manually in the cloud becomes very boring and very repetitive, much more so than when you have your own hardware, right? But even if you have your own hardware, on-premise stuff, infrastructure as code is essential, right? I'm not sure if there's any operations people here, but if you've ever been in the operations field, you know that if you have 100 servers running and you did everything manually, their configurations are going to be different. You're going to have done some debugging somewhere, even though you probably shouldn't have done it. And there's going to be a little setting that you tweaked, or an update that didn't really go live on one of those servers, and like they start to deviate, right? They're not exactly the same anymore. And then every time you add capacity or something, or replacing something, you're going to have to build it from scratch, and you got to figure out where were we, or go back to documentation. And it's a wasteful, it's a really boring cycle, to be honest. So defining your infrastructure as code not only saves you time when adding capacity or things like that, it's also your documentation, right? And it makes sure that your servers, like everything you got, is always exactly the same, always exactly how you want it to be, right? So this is really like a no-brainer investment. Back when I was a DevOps engineer, I was smacking myself in the head at one point, like, why did we wait like 3 years before we did this? Because the technology has been around for decades, right? Not necessarily the best technology. We have like better stuff right now, Ansible, Terraform, those kinds of things. Back in the day, like we had to struggle with Puppet and Chef and those kind of things. I know they're still around, but they're solutions that sort of surpassed those. But like it was a huge win, like for us alone, just to be able to make sure that everything is the same and not have to debug these weird little problems that we probably cause ourselves by doing stuff manually. Next up, database changes, right? Those changes to database schematics, you can easily automate that. The technology's there by now. No reason to have to do any of that manually. And again, if you automate all those things, and it's going to be part of your documentation as well. So you have a little bit of history, and if something goes wrong, it's easier to identify where it went wrong, as opposed to doing all these things manually. Triggers, deployment, like there's so much to this, right? There's so much more you can automate if you want to. And this is really a lot of work if you're trying to do this all at the same time, which is why I put them in this order for a reason, right? Test automation, low-hanging fruit, infrastructure as code, mostly low-hanging fruit. And then when you're looking at database changes, triggers, deployment, and all kinds of other things, it becomes a little trickier. Again, I'm pausing for any questions. I'm not seeing any questions in chat yet. All right, so if there's no questions, let's move on to measure everything. Measuring is incredibly important because it allows you to make database decisions instead of like that gut feeling kind of decisions that you're used to making. But it also allows you to monitor things, right, and make sure that everything is heading in the right direction. Just to go back to the first point, right? Having insights into your application's performance, into what happens at certain times of the day, can really help you in your automation, in making sure you're doing the right things. It can even help you save money, right? Back when we started automating, I don't know how many years ago, and we started monitoring all kinds of stuff. Like we noticed that we had so much unused capacity at night, and it was like, duh, we sort of like knew that before, but this really allowed us to fine tune what capacity we had when, and like use the unused capacity at night for other things. And it wasn't until we started measuring that we became much more effective at this. Before the time, we used to like run our backup cycles at 5 a.m. Turns out that a bunch of our customers were using their applications very, very heavily at 5 a.m. And we thought, well, nobody wakes up before 6, right? So apparently they did. They woke up at 4, bakeries. And so that data allowed us really to optimize the whole for all of our users. But it's not just production, right? It's also about builds, about tests, about the environments you're running. Builds, you want to make sure that all your tests pass every time that your software keeps on building. You want to monitor all the tests that you're running and get like a proactive notification in case something goes wrong so you can back in and fix it. But we're also talking analytics, like I mentioned before, like performance, application behavior, logs. You can even monitor user interfaces, response codes, APIs, like all these kinds of things you want to keep an eye on. And I think especially APIs these days is over the past decade, APIs have become much more important because software applications have become more decoupled and they rely more heavily on APIs, which is a very good development. But that makes APIs much more important. So you want to really monitor your APIs that they keep doing what you expect them to be doing, not just from a unit test perspective, but also from a running a production perspective. And then finally, there's stuff like code analysis, right, that you want to keep ongoing for security, for performance, for semantics, all these kind of things. And fortunately, the last one is typically pretty simple to do. Analytics can be a little bit more tricky. Monitoring really depends on how much effort you want to put into this. But you want to measure as much as you can. Measurement isn't typically a big expense. It's just having to set it up. Just that getting started is a little bit of effort. But once you have all that data, you can start using it to drive decisions. All right. I'm going to pause again, see if there's any questions. All right. And then finally, last order of camps is share everything. And I guess to start, the most important thing for me in this one is the internal open source model, like Spotify has set out in their engineering culture videos, but I know many more organizations do this. And that's a very effective way to break down barriers, right? To start breaking down that wall. It's like these trivial things where one team needs you to do something that they can just as well do themselves, but for whatever reason, they cannot do it. They cannot like access your code or make changes or whatever. And I've seen so many organizations and teams stumble over this and get frustrated. And it's like, we need something for this team. We requested it 7 weeks ago and the product owner keeps telling me no, and it's like a 15-minute fix. But it takes the team like 4 hours to go back in the code, et cetera, et cetera. And then they started sort of opening this up under the precondition that the team that owns the code does a code review, but anybody else is like free to submit changes. It changed things considerably, right? Because now you can make a change and somebody else just reviews it, which is really typically literally like a 5-minute job, and you can do it at the end of every day, start of every day, for example. And that sort of internal open source model really sped up value delivery because there were no more time wasted on waiting on other teams and lots of communication overhead and scrums of scrums where you need to escalate things. And like, you don't really have that if there's like an open model of collaboration. Another one I just mentioned for sharing everything is code reviews, right? This code reviews are very useful. For a couple of reasons. First of all, it helps with like the 4I principle that multiple people have seen the code before it finally gets pushed to production. It also helps with knowledge sharing because people see the code that you wrote, review it, and that sort of automatically helps that with that internal in-team knowledge transfer. But it's also like sort of like a fallback. Like sometimes you have a bad day, you forget something, or you make a solution that you think is good, and somebody else says like, "Hey, wait, if you make this little tweak, it'd be twice as fast," right? So code reviews are really powerful, and I can't encourage people enough to do it. But sharing everything goes beyond that, right? It includes new ideas you have, discoveries you make as a team. These are very straightforward things, and they're very easy to share, and they have a big impact, right? So, except for example, just a piece of hands-on advice here for new ideas and discovery. The organization I used to work for ran into the problem where there wasn't enough of that sharing. Like people were doing like awesome discoveries, they built new stuff, they created like new algorithms that could help others, but we didn't know about it because we didn't really talk to each other. So every week we started doing something called lightning talks. So every Friday afternoon from like 11:30 to noon, 11:30 a.m. to noon, we set aside those 30 minutes for lightning talks. We had 3 slots at 10 minutes, and the first 5 minutes of the slot, somebody would give like a quick presentation, a lightning talk, and then the next 5 minutes were for discussion. And if the presentation was 4 minutes, you have 6 minutes for discussion, but the presentation was never to last more than 5 minutes. And then we would just like, everyone was in the schedule, you would just, your name would be on the list, and it was your turn at one point, right? So this was not only a platform for people to share their discoveries or inventions or new ideas, it also forced people that probably did not have anything to share to think about what can I share, or maybe ask questions about, hey, I wrote this piece of code, what do you think about it? Or I'm struggling with this. And that really opened things up, that really opened up that whole communication. And I think we started doing it in 2011. They're still doing it. I know for sure if I'd be going there, it's on the other side of the planet for me now, but if I'd be going there this Friday, 11:30 a.m., I know they'd be still doing it, right? Because it's so incredibly powerful. And that sharing, that really helps the organization get more mature. And finally, there's stuff like tools that you discover, like I mentioned before, experiments, results of experiments, like I tried this, it failed, I tried this, it succeeded, these are the lessons learned. And again, for those last 5 things, like lightning talks are really like an awesome platform. And if it's interesting enough, like if you got good stuff to share, then people will keep attending, right? Because they know this is interesting, and they know like, hey, I have to share something too. So it's really some sort of self-reinforcing mechanism. So that was CAM. So again, pause briefly for questions before we move on to DevOps stages.
Good stuff, Martin. Thanks.
Thanks, Tom. Good seeing you again.
Good seeing you too, man.
Awesome. I even recognize your voice by now. All right, so moving on to the DevOps stages, right? So how do you move through this? So stage number 1 really is that first slide that I had at the start, right? So dev built something, they have their own little backlog, they have their own little releases, and they throw it over that fence to operations, they start doing it. And it's just see the time to deploy at the bottom, like the little T and arrows, like can be anywhere from you throw it over the fence until like infinity. You don't really know, right? And the responsibility for bugs, the little bug at the top, is typically with ops, right? In any case, if something goes wrong, they're the first ones to get paged. They're the first ones to get pinged. They're the ones to take the initial blow. And then ultimately they might have to go back to the developers to get it fixed. But they're having to do triage and all that kind of stuff, right? So it forces them into sort of buying into a very uncomfortable position where, yeah, they if they're not really sure it's going to run, they're going to be hesitant in putting it in production, and that's not what you want, right? Because you want to get that value out there. So that's sort of like traditional environment. So if you start breaking down that barrier a little bit, you're going to be moving to stage number 2, is where it's not like, hey, we're going to throw it over the fence, but it's going to be like, hey, operations, this is what we built. Why don't you have a look at it? Do you feel comfortable putting this into production? Yes or no? So like inviting them over to look at your code at your desk or the application or whatever, before they put it in production. It's sort of like the first step towards building that trust. They are still responsible for all of that, right? But what you'll notice is they're much less hesitant to put it in production, and they're more inclined to deploy it quicker, right? And the other side of the coin, like if something's wrong, you're more likely to catch that before something, moves into production. So as you start like taking down that wall, you're moving towards number 3. Stage number 3 is really where Dev and Ops start becoming one team and start not just shipping the box, but making sure it's like properly wrapped up and taped shut and everything. So they really start delivering true value. And then typically a small ops teams remains for just the trivial stuff, hopefully by the time trivial stuff of moving into production. So they have to own the Kanban board of what needs to happen. But most of what they get is like ready to ship out. There's just like a very quick last inspection in the act of putting it in production. But you've basically achieved DevOps into the teams. And one crucial difference between 3 and 4 is that there's still operations work that needs to be done. That's not necessarily related to the work that people develop, like server maintenance, upgrades, hardware replacements, migrations, all those kind of things, right? Outages you might have to deal with. That still remains with ops in stage number 3. And in stage number 4, that also moves into those DevOps teams. And what you'll notice, for example, is that the true operations people, so to speak, because you're a singular unit. And I'm picking up some background noise from someone. The true operations people who've traditionally done that, they'll meet every week or so and look at the stuff that they need to think about, just as you have your designers meet, right? Or your developers meet, or your database experts meet, or your business analysts meet. They still have that, but everything is sort of like part of the team now. And that's when you will have truly achieved DevOps, as I think it was originally intended. Any questions about this? If not, then let me give a couple of tips on what I think can really help you be successful along this journey. So extreme programming. Extreme programming has been around for 23 years. That's a great question, Dan. I'll get back to that after this, if that's okay with you. And there's a lot of practices in XP that can definitely help you be successful at DevOps, right? A lot of stuff like code reviews, even stand-ups are in there, right? That was before Agile became a defined thing. A little bit after Scrum became a true thing, and all kinds of other practices like unit testing's in there too. The first sort of way of test-driven development's in there too. So there's all kinds of really great practices in XP that you can start using straight off the bat, and that will help you move towards DevOps. CI/CD is the next thing: continuous integration, continuous deployment, continuous delivery. Sorry. That's more like a goal you're setting for yourself, I'd say, than what you're necessarily doing from the outset, because achieving continuous integration can be tricky. It can be tricky just to start doing it right today, right? Ultimately, it's what you want to achieve. Same with continuous delivery, but continuous delivery is really like when you're sort of in stage 4 of DevOps. Important thing, obviously, is flow, right? I think that's a lean part that any organization wants. It's nothing new. It's what organizations have been pursuing for decades, making sure that you like stuff like from request to production, like flows through the organization quickly and effectively without any waste, right? And things like Kanban and Scrum can definitely help with this. But the closer you get to DevOps and the operations side, the more you're going to have to rely on things like Kanban, because you'll notice that in addition to like the backlog work that you typically have, there can be stuff that needs to be worked on straight away. And if there's operations and bug responsibility within the team, you're going to have to figure out a way to deal with those things quicker or differently than how you would deal with other kinds of work. Continuous feedback is also very important, regardless of what structure you have, like whether it be Scrum, Kanban, or Safe, or Less, or whatever kind of frameworks you're working with. Continuous feedback on anything you do is important. So it's on your application work, on your software that you're building, your systems that you're building, but also in the team, your ways of working. And especially as you start breaking down these barriers, it should be an ongoing conversation. Like, how's it going? So, hey, ops, we tore down that wall. Now you're looking at how do you think it's going right now? What changes can we make to do it better? And same the other way around. Like, ops gonna say to dev, like, hey guys, this is awesome what we're doing. If you could just make sure you're doing X, Y, and Z before you show it to us, that'll really shorten the amount of time that we need to spend on this. So continuous feedback is incredibly important. And again, I can't emphasize this enough: infrastructure as code. If you reach a certain level of maturity, your infrastructure will become tied to like certain versions of your application. And that is exactly what you want to happen, right? You want to make sure that if you launch this feature that builds on this library, you don't have to worry about that anymore. Like, everything migrates automatically. Like, it just upgrades or installs that library like as you deploy your software. So it becomes like really fire and forget. And as I said, that's a certain stage of maturity, but if you're there, it's extremely comfortable. I can tell you that from experience. So infrastructure as code, if you've never explored it, I can definitely encourage you to. All right, so having said all that, obviously feel free to ask questions, share questions. I'm gonna get to Dan's question first in chat. So how do I feel DevOps differs from site reliability engineering? I'm not sure if to which degree it differs. I think there's a lot of overlap between the two, actually. And which is what I said at the start. I think there's different terms for DevOps. There's different explanations of DevOps, but there's also different terms that were introduced to mean the same thing. And the client I was at, like last year and the year before, invested heavily on SRE, and I really didn't think that was a bad thing. One of the bigger things they were focusing on was infrastructure as code. That was huge for them, right? And test automation as part of SRE, and I think that was a very good development. So I think if your focus is on site reliability engineering, I think you're basically moving towards DevOps. Was that your take as well, or?
Yeah, I think so. I mean, it feels sort of like people feel like site reliability engineering has people that are writing more code. But I think that's just, I think it just happens to be that DevOps happens to have more sysadmins in it, in my experience. But there's nothing about DevOps that doesn't mean that they shouldn't be writing code. You know,
they should be writing code, right? If you got your sysadmins, they're going to have to do infrastructure as code if you move towards DevOps. So they're going to be writing code, and that's what puts them off initially, in my experience.
That's right. Right.
Yeah, because it's a different take on things. It's no more like, hey, I got to install this application, so I'll just like run through the installer, spent 45 minutes waiting until it's the next step. I'm just like oversimplifying things, right? No offense to sysadmins, but that's a different take. Yeah. Thanks for bringing it up, SRE. Sure. Very interesting topic.
Thanks for the presentation.
Sure. Thanks for being here. Well, I wait to see if there's any other questions. The next session is going to be September 8th at 5 p.m. Eastern time, 3 weeks from now. I am still looking for a topic for that one. If there's somebody in the group that would love to present something or has a suggestion for a topic, feel free to do so. Otherwise, I'll make up one myself and publish it tomorrow.
Thank you so much, Dan. Martin, sorry.
Oh, this is great, Martin. Thanks again for presenting.
Sure, anytime.